Hi Calculus 3 students. In this example, we're going to find the Taylor series of cosine of x at x equals pi over 3. Um, so it's very easy to find this Taylor series of cosine of x at 0. At pi over 3, we will see that there's a slight complication that is involved by this choice of value of x. What you should always do when you try to find Taylor series by differentiation, in other words, by using the definition, is to actually set it up a little bit like a table, right? You go like f of x is equal to cosine of x, all right? We know that already. But it means that f of pi over 3 is equal to 1/2. Okay. Then you will do the derivative and you will calculate f prime of pi over 3, f prime prime of pi over 3, and so on. So, okay, f prime of x is negative sine of x. The derivatives are very simple, right? So let's just have a couple of them. Negative cosine of x, f prime 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 of x is sine of x, okay? Then f4 of x is going to be the cosine of x. And let's have all the way up to the fifth derivative. You will see why. Okay, so let's have all of these derivatives. Obviously, this continues, but we have to stop at some point. Then we calculate what are these derivatives at pi over 3. So, okay, f prime of pi over 3, so that's the negative sign. That's negative root 3 over 2. Then with the cosine, we have f prime prime. That is, as you can see, it's going to be negative 1/2. Then f prime 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 is going to be the positive root 3 over 2. And then the fourth derivative at pi over 3, as you can see, is going to be, again, 1/2. And the fifth derivative, just to end this up, pi over 3, is going to be negative root 3 over 2. Okay, so there is something to tackle about the signs, but there's also something to tackle about the values, right? The values alternate between 1/2 and root 3 over 2, but the sign also has a weird pattern, right? You have like a double positive with a double negative. So how do we handle that? The idea is to split this Taylor series into two series. One of them that's involving the 1/2, and one of them that's involving the root 3 over 2. So let's use two different colors. Let's use green and orange. Okay, why not? So let's start with the series that is involved with the 1/2. So all these terms right here, okay, all these terms involve a 1/2. And notice that we are counting the terms 0, 2, 4. Okay, so 0, like we have the second, we have the fourth terms, and etc. Okay? So it means that for this green series, we will completely disregard the odd terms. So the series will look like this. Now, as you can see, it's also alternating in signs. So here we have like the... So in other words, it's going to look like this. We're going to have the sum from n equals, let's say, 0 to infinity. We're going to have negative 1 to the power of n, but now this is because it's alternating. We have like positive, negative, positive. So like that's the signs over here. This is responsible for the negative 1 to the power of n. And now we need to jump over the odd derivative. So we're gonna have here we're gonna have our 1/2. Okay, so multiplied by 1/2, and then we're gonna have x minus pi over 3 to the power of 2n, right? This 2n is important because we're counting only the even terms. And this also means that we're going to divide by 2n factorial. Okay, now this is the series only if we count the even terms. So to that, we must add a series that is counting only the odd terms. So in other words, here we have so this term right here, okay, this term and this term. Okay, so let's put arrows. These are respectively like the first term, the third term, the fifth term, and so on. So we have to write a series for these. Actually, I use red instead of orange. No problem here. So let's have a look. We have the sum. Now, this sum starts at 1. You can also start it at 0, though. Not a bad idea. Let's start it at 0. So start this at 0, and we're going to handle this with the power. So start it at 0. N is starting at 0 and it's going to infinity. One thing to keep in mind is you also have an alternation, right? You have negative, positive, negative. But in this case, you're starting with a negative. So you have to be careful. So we're going to write it like this. We're going to write it as like negative 1 times negative 1 to the power of n. This one will alternate, but it will start positive. So the extra negative 1 here will make it negative. So let's start like this. Then we have the value, root 3 over 2, that we put here. And then I think I'm going to have to erase this, push this a little bit here, just so that I have the space to complete it. So here we go. We have n is equal to 0 to infinity. Now we said negative 1 times negative 1 to the n. You'll see why I write it like this. Multiplied by root 3 over 2. Then what do we have? We have x minus pi over 3. Now we're counting only the odd numbers, which means we're going to have to the power of 2n plus 1. Okay? And that is divided by 2n plus 1 factorial. Whenever you write 2n plus 1, keep in mind that you're starting at 0, right? You have to make sure that you, when you replace n with 0 or n by 1, depending on what you write here, you have to hit the first derivative. So if we chose to start the series when n is equal to 1, we would have here to write 2n minus 1 instead of 2n plus 1. So this is something to keep in mind. Okay, well, the total Taylor series, so the Taylor series is the sum of these two series. These two series, okay? This means that what we have to write down, we have to write down the green series plus the red series. So let's actually start with that. We have the series when n is equal to 0 to infinity of negative 1 to the n over 2. Let's try to save some space. X minus pi over 3 to the power of 2n over 2n factorial plus the red series, the red that we have right here. So from n equal to 0 to infinity, negative 1 times negative 1 to the power of n, root 3 over 2, x minus pi over 3, I hope we have space here, 2n plus 1 over 2n plus 1 factorial. Okay, very good. Because now what you're going to try to do is to combine as much as you can. So in other words, let's look at what are the common factors. What can we possibly take out? So there is a common factor of -1 to the n that is there in both sums. And there's also a common factor of 2, right, at the denominator. So now what we're going to do is we're going to write this as only one series starting as n is equal to 0 to infinity. And now we will have that -1 to the power of n. We will have that over 2. But now we need to add up the rest. So we open a bracket. We add what's left of the green series that we cannot combine. So we're gonna have that x minus pi over 3 to the power of 2n over 2n factorial. And now be careful of that extra -1, right? That is not common to both terms. So what will happen is that we will subtract, that's what the -1 is responsible for, the root of 3 times this part. So x minus pi over 3 to the power of 2n plus 1 over 2n plus 1 factorial. So I'll frame this as my final answer. So this gives you the Taylor series of cosine of x at pi over 3. So as you can see, sometimes you have to think of splitting the series into two kinds of terms in order to write the full Taylor series. I hope this was helpful. See you in class or in the next video.